So last class we talked about the sampling distribution of p hat. Today we're going to talk about the sampling distribution of x bar. And remember that x bar is the statistic that estimates mu, the parameter. And so we have to ask ourselves, how good a guess is x bar of mu? And the only way to look at that is look at the sampling distribution, so we're going to figure that out here. If we're looking at quantitative data, remember going back, quantitative data, we're going to be generally interested in statistics such as the median or the mean or the standard deviation of the variable. And sample means is going to be one of our most common statistics that we'll ever see, the sample average. So if it's a categorical variable, we're chasing p and we're estimating it with p hat. If it is a quantitative, remember quantity means count, something we measure, then we're generally going to be chasing mu and estimating it with x bar. So let's say we have a graph of household earnings. Now this is clearly not approximately normal. It's obviously right skewed. And so here is mu. Here's the average household thing. And what you'll notice is that the standard deviation of the sampling distribution is much, much less, but is also centered at the exact same place. So they have different shapes, right? But they have the same center, and they have different spreads. And so we're going to have to look at a little bit more detail here when we get into the sampling distribution of x bar and what kind of shape it's going to have. Generally, this is fairly simple. The center of the sampling distribution of x bar is mu. So mu x bar equals mu. The standard deviation of x bar is the standard deviation of the population divided by the square root of the sample size. And this is true as long as we sample less than 10% of the population. That's what that's saying. This means sample less than 10%. Because little n is sample size, and big N is population size. So once we have this information, then we can describe the sampling distribution, or we can describe the center, and the spread, but the shape gets a little tricky here. Is the shape, once again, so there's our descriptions, but is it approximately normal? Well, the reason that we don't talk about the shape is because it depends. So for today, we're going to talk about it. If we're sampling from a normal distribution, or a distribution, if the population distribution is normal or approximately normal, then so is the sampling distribution of x. And this is true no matter what the sample size is. So as long as we sample from an approximately normal population, then our sample size will be, our sampling distribution will be approximately normal. So we could not have said that here because this is non-normal, right? This is definitely skewed. And it's definitely right skewed. So while this shape is mound shape, we cannot yet say that it's approximately normal. Right? We can't say that. We don't know what the shape of it is. We know what the center is, and we know what the standard deviation is, but we don't know the shape of it. But if we sample from an approximately normal population, like let's say this is people and we were measuring height. Well, we know that height's a normally distributed variable, so the sampling distribution of x bar would be approximately normal. And then we can start doing the normal probability calculations we did last time. Now, the question you're probably going to ask yourself is, what do we do if we're sampling from a non-normal population? And the answer to that question is, I will tell you in the next video. It's always important that we double check that 10% condition. If we sampled more than 10%, then we have to make an adjustment to this formula. But in general, the standard deviation of the sampling distribution of x bar is the standard deviation of the population divided by the square root of the sample size. All right, so that's it for the video. Everybody enjoy your break. And or if you've already had your break and are going back to school tomorrow, we'll see you soon. Bye-bye.